In this video, we're computing the integral of cosine squared of pi x on the interval 0 to 2. So we're going to start with a quick symbolic solution here, but then I have a couple words to say about the geometry that's going on behind the scenes. So to get this thing solved symbolically, we have an even power of cosine and we apply the power reducing identity for cosine squared, and that's 1/2 times 1 plus cosine of twice the angle. As we write down the next step, we're going to pull the 1/2 out in front. And inside of our integral now, we have a 1 plus cosine of 2 pi x dx. And now we just have to guess the antiderivative of each one of those terms. So I have a 1/2 out in front. And then for my first term, that integrates to x. In my second term, it integrates to 1 over 2 pi sine of 2 pi x. And there I'm just seeing the chain rule backwards. That 1 over 2 pi is there to make it so if I differentiate 1 over 2 pi sine 2 pi x, the chain rule produces a factor of 2 pi, and the 2 pi's cancel, and I get back to where I started. Now we're evaluating this all from 0 to 2. And let's focus on that sine containing term real quick. If I sub in the upper limit to that, I get the sine of 4 pi, which is 0. If I sub in the lower limit, I get the sine of 0, which is 0. So that whole term is gone anyway. Now if I sub in the lower limit to my x, that gives me 0, so the lower limit is totally irrelevant to the solution. The only thing that matters is subbing in the upper limit to the x. So I end up with a 1/2 times 2, and it turns out the answer for our definite integral is just 1. So it turns out there is a trick we could have used to get around all the work in this problem. So let's take a look at this function. There's cosine squared pi x on the interval 0 to 2, and what I notice here is I've completed 2 full periods of the cosine squared function. Now, if you happen to remember that the average value of the cosine squared function on an integer number of periods is equal to 1/2, and I'll post a link to where that fact was first derived, then all we have to do here is take that average value of 0.5 and multiply by the interval width of 2, and we get the same exact area of 1. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.